Dear students, we are on the CEC Gurukul lecture and today's topic is the resistors. We are defining the type of resistor. Resistors are defined by the two types, linear and non-linear resistors. The linear resistors are also divided into two categories. One is the fixed resistor and second is the variable resistor. So here we are discussing the fixed resistor. The types of fixed resistors are carbon composition resistors, wire wound resistors, thin film resistors and the thick film resistors. One by one we will discuss these resistors. First is a carbon composition resistor. Basically this is the fixed type of resistors which is made from the mixture of granulated or the powdered carbon or the graphite, insulation filter and the resin binder. The ratio of the insulation material determines the actual resistance of the resistor. Then binder used to make a shape of the rods. There are the two metal caps on the both of the end of the rod. There are the two conductor wires on the both the ends of the resistor for easy connectivity in the circuit while soldering. That wires can be connected with the electronic circuit. And the plastic coat cover that the rod with different color coding are enveloped on it, which denote the resistance value. Their available values are 1 ohm to 25 mega ohms in the power rating from 1/4 watt to up to the 5 watt. So these are the carbon composition resistor on the screen. You see here the various value are here. Here it is a color code mentioned on the cover and components, the carbon composition defined here, and where we see that the various type of carbon composition resistor of the 2 watt, 1 watt, 1/2 watt and the 1/4. Second is the wire wound resistor. Wire wound resistors is made from the insulating core or the rod by wrapping around the resistive wire. And these resistive wire basically are made from the tungsten, manganese, nichrome and the nickel or the nickel chromium alloy, and the insulating core is made from the porcelain, bakelite, press bound paper or the ceramic clay material. So wire bound resistors are basically very costly and used with the sensitive test equipment like in the Wheatstone bridge, and they are available in the range of 2 watt up to the 100 watt power rating or the more. The ohmic value of these type of resistors in between the 1 ohm to the 200 kilo ohm, and then can be operated safely on the 350 degrees centigrade. Moreover, the power rating of this type of resistor is 500 watt and is available resistance value of the resistor 0.1 ohm to 100 kilo ohm are available. These are the diagram as you see on the screen here, that this is a wire bound resistor. Wire bound resistor used very high sensitivity, accurate measurement and the balanced current control which is required as a shunt with the ampere meter. You see on the screen, most of the time you have seen this type of instrument in the laboratory. That is, this is the wire bound. Now the connection lugs are there on the both the side, and left hand side you are seeing the mounting brackets and the wire which is in the shape of a wound wire resistance element, and the coil is wrapped on it, and then the ceramic former is on which the wire is wrapped. So this is the wire bound resistor. Moreover, the wire wound resistor are generally used in the high power rating devices and equipments. For the testing and measuring devices it is used. To control the equipment it is also used. Next is the thin film resistor. Thin film resistor are made from the high grade ceramic rod and the resistive materials, and these are and next is the thin film resistors. This thin conducting material layer overlaid on insulating rod, plate or tube which is made from the high quality ceramic material or a glass, and the size is it is in the form of the thin film. And there are the two further type of the thin film, like the carbon resistor and the metal film resistor. Carbon film, where we use the carbon film resistor are those which contains on a insulating material rod or core which is made of the high grade ceramic material which is called the substrate. Substrate is used here, and very thin resistive carbon layers are overlaid around the rod. That's why it is a carbon film resistor. And these kind of resistors are widely used in the electronic circuit because of negligible noise and wide operating range and a stability as compared to the solid carbon resistors. This is the carbon film resistor on the screen, and you see there is marked 1, 2, 3, 4, 5, 6 component are here. First is the color coat, second haloxing, third is the film which is coating on it, that is a carbon film, fourth is the substrate, then 5 is the insulation to cover it, then 6 is the terminal and lead, and these terminal connect with the electronic circuit. Next is the metal film resistors. Metal film resistors are the same as construction like the carbon film resistor, but the difference is that here we use the mixture of the metal oxide and nickel chromium, or the mixture of the metal and the glass which is called the metal glaze, which is used as a resistive film instead of the carbon. In the carbon film resistor we use the carbon thin film coating on it, but here we use the metal oxide film. That's why it is a metal film resistor, and it is very tiny, cheap and reliable in the operation, and temperature coefficient is very low, that is plus minus 2 ppm per degree centigrade, and used where the stability and the low noise level is important. This is the type, just you see is similar as the carbon film resistor. This is the metal film resistor. On the screen you can see these are the various part 1, 2, 3, 4, 5, 6. First represent the leads, second is the end cap, third is the ceramic, and fourth is the metal film. Then we are having a epoxy coating and color bands are there, color bands to get the value of it. Now next is a thick film resistors. The thick film resistors like a thin film, but the difference that the thick film instead of the thin film coated on the material, coated on that resistor, like the layer of the resistive material around it, we use the thick film as compared to the previous resistor. That's why it is called the thick film resistor. There are two additional type of the thick film resistor, like the metal oxide resistor, ceramic film resistor, and then fusible resistors. One by one we will discuss. Metal oxide resistor, as the name suggests, we use the metal oxide here in it by oxidizing a thick film of tin chloride tin chloride on a heated glass rod. So on a substrate, glass rod is worked as a substrate where we oxidize the tin chloride film on it, but the thickness is more, is a simple method to make the metal oxide resistors. And these resistors are available in the wide range of resistance with the high temperature stability also, and they are having a very low noise and can be used at a high voltages. Next is the network resistor, that is a ceramic oxide resistors, we can also call it network resistor. The internal area contains an ceramic insulation material and then carbon or a metal alloy film layered wrapped around the resistor, and then fix it is a ceramic metal, and which is known as a cermet. That's why it is called a cermet, because we are using a ceramic layer on it. Cermet oxide, they are made from the square rectangular shape, and lead and leads the pins are under the resistance for easy insulation in printed circuit board. Now you see on the screen that this is the type of the ceramic film resistor. These are having a terminals so that it is easily put into the circuit or in the broadband, and they provide a stable operation in a high temperature because their value don't change with the change in the temperature. They can work on the various temperature also. Next is fusible resistors. These kind of resistors are same as a wire bound resistor, and the power rating increases a specific value, and this resistor is fused, that is fusible resistor is called, and break opens, and it's break or open the circuit, that's why it is called fusible resistance. Fusible restores the perform the double jobs, means that it limits the current as well as it can be used as a fuse. This fusible resistor used as a fuse. It limits the current as well as the fuse. So one of the application is this, and it is used widely in the TV set, amplifier and other expensive electronic devices, and its resistance, fusible resistors, is less than of the value of 10 ohms. Next is the variable resistors. Up to now I would discuss about the fixed resistors. These are the types of the fixed resistors. Now we discuss the variable resistor. Fixed resistor whose value cannot be changed. Now the variable resistors whose values can be changed through a dial knob or a screw or manually by the proper method. In this type of resistor there is a sliding arm which is connected to the shaft. The value of the resistance can be changed by rotating the arm. It means this value can be controlled. They can be used the radio receiver or the volume control or the tone control resistance. Most of the time you have seen in the electronic devices as well as in the laboratory as well as in the house. There are the variable resistors. What is the variable resistors? Through which we can change the value manually or the digitally. These are the various type of the variable. What are the types of variable resistors? Here we define the three types of the variable resistor. First is the potentiometer, second is the rheostats, and third is the trimmer. These are the variable resistors: potentiometers, rheostats, trimmers. Rheostats, potentiometer, rheostats, generally we use in the laboratory experiments, and you all people have seen these rheostat and the potentiometer in the laboratories. Now we discuss what is this potentiometer. Potentiometer is a 3-terminal devices which is used for controlling the level of the voltage in the circuit. The purpose is to control the voltage, is to flow of the current. So potentiometer is a 3-terminal devices which is used to controlling the level of the voltage in the circuit, and the resistance between the two terminals is constant, while the third terminal is connected with moving contact, which is variable, in which two values will be fixed and one value will be variable. The value of the resistance can be changed by rotating the wiper which is connecting to the control shaft. Two value fixed, one is changed by using the wiper. Next you can see here in the diagram, this is a type of potentiometer, and this potentiometer can be used as a voltage divider, and these resistors are called the variable composition resistor, and they are available from the 10 mega ohm. On the screen you are seeing the potentiometer, where it contains a carbon track which is coated with the carbon, rotating wiper, one will be changed, shaft one value will be changed. Now you see here, see the B value is changing. Now the resistive material by which we can prepare this device, this potentiometer, and next is a terminal. A and B are fixed terminal, but B is a variable terminal. You see rotating wiper through attached here with. On the right hand side, this is the laboratory used potentiometer, which is having a various part wiper and terminal 1, terminal 2, and control shaft here through which we can control the value. So these are this is the potentiometer construction. Next is the rheostat. What is this rheostat? Rheostat is also having the 2 or 3 terminal devices which is used for the current limiting purpose by hand or manual operation. You see in the laboratories that by moving it we can limit the current also. The rheostat is also known as the tapped resistor or variable wire wound resistor. You see this, you have always seen in your laboratories. You see here on the screen there are the screwdriver rheostat. There are this type of rheostat make wire which is wrapped on the various materials, ceramic core, and then assembled in the protective shell. The metal band wrapped around the resistor element, and it can be used as a potentiometer or the rheostat. And there are the difference between the rheostat. This is the rheostat which is having the wire wound adjustable tap that can be moved from one side to the another side. Both the terminals are there, which are used to connect in the circuit. So this is the screwdriver rheostat. You see, most of the time you have seen in your laboratory, and that we will change the current by changing the sliding contact here. You see, we are having the two terminal A, terminal B. Moreover, in between the two terminals there is a sliding contact. Coil is wrapped on the ceramic material. Now screwdriver that will be connected with the control resistance. We are having the variable wire wound resistors are available in the range of 1 ohm to the 150 ohm. The available power rating is 3 to 200 watt, while the most used rheostat according to the power rating in between the 5 to 50 watt. Now wire wound rheostat having the resistive material and the sliding contact, as well as two side are fixed, a low resistance side and one is the high resistance side. In between that there is a wiper that this value will be changed. So this is a variable type of resistor. Now next is the trimmer. Trimmer is having the additional screw with the potentiometer or variable resistance for the better efficiency and operation, and they are used as a trimmers. The value of resistance can be changed by changing the position of the screw to rotate by the screwdriver. Now see, this is the various type of trimmer which are used in the laboratory. Now this is made from the carbon composition compound, carbon film, ceramics are used to make it, and wire materials are available in the range of 50 ohm up to the 5 mega ohm, and the power rating of these trimmer potentials are in between the 1/3 to 3/4 watt. So these are the various type of the linear resistor. Linear resistor divided into fixed and variable, all we have defined. Now we come on the non-linear resistors. What are the non-linear resistor? Non-linear resistor are those resistors where the current flowing through it does not change and according to Ohm's law, but change with the change in the temperature or the applied voltage. So non-linear resistors are those resistors where the current flow through it does not change according to the Ohm's law, but changes with the change in the temperature or the applied voltage. Now in addition, if the flowing current through the resistor changes with the change in the body temperature, then these type of resistors are called the thermistors, and these thermistors are basically used in the medical purposes also. So if the flowing current through a resistor changes with the applied voltage, then it is called a varistor, VDR, voltage dependent resistor. So there are the various type of the non-linear resistors. So non-linear resistors are divided into these three categories. First is the thermistors, second the varistors, and third is the photoresistor or the photoconductive cell, or it is also called a LDR. First we discuss the thermistors. What are the thermistors? Thermistor is a two-terminal devices which is very sensitive to the temperature. Thermistor, that is related, thermistor, the name suggests that related to the temperature. Thermistor is a type of variable resistors which notices the change in the temperature, and it is made from the cobalt, nickel and the metal oxide of the manganese. So resistance of the thermistor is inversely proportional to the temperature. Resistance of thermistor is inversely proportional to the temperature. temperature, the resistance increases, temperature decreases, and vice versa. Thermistor has a negative temperature coefficient, that is also defined as NTP, but there is also a PTC, positive temperature coefficient, that is made from the barium titanate semiconductor material, and their resistance increases when increases with the temperature. So there is a different type of two type of thermistors. First is the negative temperature coefficient, who is inversely proportional to, and second is a positive temperature coefficient, which is made from the titanate semiconductors materials, and where the resistance increases with increase in the temperature. Now on the screen we are having a various type of the thermistors that are used in the devices, in the medical purposes also. And next is the varistors, that is VDR. Varistors are voltage dependent resistors, VDR, which is used to eliminate the high voltage transients, means in order to specific value of the variable resistance used to protect the circuit from the destructive voltage or spikes the voltage, means it will control the voltage. So that's why it is a voltage dependent resistors. Then voltage increases due to lighting or due to line fault across the connected sensitive devices or the system. This will reduce the level of the voltage to secure the level and change the value of the voltages and secure the devices. So these are the various type of the varistors. Now it is dependent upon the voltage. Next is the photoresistors or the photoconductive cell, or LDR, light dependent resistor. That was the voltage dependent, this is the light dependent resistor. Photo name suggests the photons are used or the light are used. The photon resistor or LDR, light dependent resistor, is a resistors which terminal value of a resistance changes with the light intensity. And in other words, those resistors which resistance value changes with the falling of the light on the surface is called the photoresistors, and photoconductive and LDR, light dependent. The material used to make this type of photo resistors are cadmium sulfide or lead sulfide extra. These materials are used to prepare these photo resistors. And these we can see on the screen, they are the various type of the photo resistors. These are the LDR, this is called the LDR. Here we are having a transparent coating over the surface, and below it we are having a various material, right. Also it is known as a photoresistor or photoconductive. Now on right hand side you see, and this most of the time we use in the laboratory this type of photoresistors. When the light falls on the, you see very clearly that transparent surface it is having, so that light fall upon it very clearly on that, and the value will be changed. So when the light fall on the photoconductive cells, LDR, the photoresistor, then there is an increase in the free carriers of the electron or hole pair due to the light energy, and which reduce the resistance of the semiconductor material, and the quantity of the light energy is inversely proportional to semiconductor material, and it means photoresistor have a negative temperature coefficient, and it depends upon the light intensity, it will work in that manner. Reduce the resistance of the semiconductor as the light intensity is inversely proportional to the semiconductor material. More the light, the less the resistive, less light, and it will be light energy is inversely proportional to the semiconductor material. Next is a SMD resistor, that is the surface mount technology, surface mount resistors. That type of resistors is the surface mount devices, and these resistors are very tiny, like a tiny chip, and marked with the 3 and 4 digit codes, which are called the SMD register, that indicate the resistance value. And below of some given rows which help to know the exact value of the SMD register on printing the character code on that tiny chip. Now you see on the screen that 472 that mention the color code, and there are various type of the surface mount resistors. What are the application of the resistor? Up to now we discuss about the various type of resistors. Like resistors are divided into two categories. First is the linear, second is the non-linear. The linear divided into again two categories, variable and fixed register, and all are having its different types of registers, and these registers are used in the electronic devices. Then what are the application of the register? Practically both type of register, fixed and variable register, are generally used in the following purpose, where we use the controlling. When we want to control the current, then we use this registers. To change the electric energy in the form of the heat energy, we use the resistors. Shunt in the ampere meter, we use the resistor. As a multiplier in the voltmeter, we use the resistor. To control the temperature, to control the voltage drop, we use the resistor. So there are the various type of resistor, and these resistor having a various type of application, like the fusible resistance are used as a fuse, and it is used as a protection purposes, just to save the device to damage. So in the laboratories we will use various type of the registers. Voltage control resistor, that also used to save the device just flow of the extra voltage in the devices. Most of the home appliances, electrical appliances, we use the resistors. In the heater, in the iron, in the immersion rod, etc., we use this type of resistors. Widely used electronic industry resistor. Nowadays we prepare it in the we use this resistors in many devices. Moreover, when we see in nowadays we are preparing these devices of the nano sizes. So there are the basic applications of the resistors, which are practically used in daily life in the electronic gadgets. Fixed and variable resistance are used in many devices, and for the electronic and the digital devices which is made from the resistor. In the next part, we will discuss the other instrument or other devices used in the construction of the electronic circuit. Thank you very much.